where x is equal to dryness fraction of wet steam, and here this equation is called as Jenner's equation. Okay, so that's n is equal to 1.035 plus 0.1 into x. That equation is for wet steam, and that equation is called as what? Jenner's equation. Okay, then as expansion is adiabatic, what we say, the gain of kinetic energy of steam is equal to work done by steam in nozzle, and that gain is equal to 1/2 mv square is the kinetic energy. Okay, is general equation. So gain in kinetic energy, specific enthalpy if you take, or specific mass if we take, then m is equal to 1 kg, and in that case here m is equal to 1, therefore it will become v square divided by 2, but here we are using for velocity symbol as a c, therefore c2 square divided by 2 will be the final kinetic energy. Initial kinetic energy will be c1 square divided by 2, and it will become gain will become c2 square minus c1 square divided by 2, and is equal to work done in any adiabatic process is given by equation n upon n minus 1 into bracket P1 V1 minus P2 V2, and this equation you have learnt in your basic mechanical engineering last year formulae. Okay, and therefore, but we are assuming that here C1 is very small as compared to C2. Therefore, we want to neglect C1. Okay, and therefore neglecting C1, what we are getting? C1 will become 0, and therefore we are getting equation C2 square divided by 2 is equal to n upon n minus 1 P1 V1 minus P2 V2. Then only we have to now henceforth we have to make the mathematical adjustment. Therefore C2 square divided by 2 is equal to n upon n minus 1 P1 V1 we are taking common. Okay, inside bracket it will become P1 V1 1 minus P2 V2 divided by P1 V1. And that day we have discussed about this relation, that is V2 upon V1 value we want to put in terms of P2 upon P1. What is that value? If you solve this equation, PV raised to n is equal to constant, means P1 V1 raised to n is equal to P2 V2 raised to n. So in that case V2 upon V1 it will become P2 upon P1 raised to minus 1 upon n. Okay, and if you put this value, then what we are getting? So therefore V2 upon V1 is equal to P2 upon P1 raised to minus 1 upon n, and this value we want to put in this equation. So you can use equation number, any equation number, or there C2 square divided by 2 is equal to here n upon n minus 1 P1 V1 in bracket square bracket 1 minus P2 upon P1 into bracket P2 upon P1 raised to minus 1 upon n, and if you simplify it, then what we are getting? Then C2 square upon 2, or C2 square if you take, is equal to 2n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. Okay, then if you take the C2 value you are interested, C2 is equal to square root of 2n n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. So this equation is the equation for the velocity of steam at throat. Okay, then afterwards we will discuss about the condition of maximum velocity afterwards. Now everybody got this? I think up to this I think we have covered. We have covered also I think discharge through the nozzle. So discharge through nozzle is given by equation. I have explained that rho is equal to mass upon volume, and discharge is equal to volume upon mass per second is equal to more mass rate is equal to, we can say it is volume rho into volume, okay, divided by second, and it will become rho AC. Okay, but rho is equal to 1 upon specific volume, therefore mass rate is equal to AC divided by specific volume. This is general equation. We have discussed that. Therefore, at this mass flow rate remains constant at every point in the nozzle section. Therefore, m is equal to a1 c1 divided by small v1. It should be also equal to a2 c2 divided by small v2. Okay. And here we have considered that m is mass flow rate, c2 is velocity of steam at throat, and v2 is specific volume of steam at throat. Then now here m is equal to a2 c2 divided by small v2, and we are interested in mass flow rate, or that is also called as discharge through nozzle. It is also called as mass flow rate or discharge. So a2 c2 divided by small v2, as we know the value of c2, so c2 value is equal to square root of 2n upon n minus 1 p1 v1 into bracket 1 minus p2 upon p1 raised to n minus 1 upon n. Okay, and therefore m is equal to what? C2 value we have to put. Therefore, A2 divided by small v2 into square root of 2n upon n minus 1 p1 v1 into square bracket 1 minus p2 upon p1 raised to n minus 1 upon n. Okay. Then v2 upon v1. So what we are doing is, here this v2 upon v1 is equal to p2 upon p1 raised to minus 1 upon n. Therefore, v2 value is equal to v1 into bracket p2 upon p1 raised to minus 1 upon n. So instead of this v2 now, we have substituted last lecture. The value is of v2 as v1 into bracket p2 upon p1 raised to minus 1 upon n. Okay, this we have substituted. Therefore, ml instead of v2 we are putting value of equal to a2 divided by v1 into bracket p2 upon p1 raised to minus 1 upon n into square root of that parameter will remain same, 2n upon n minus 1 p1 v1 into bracket 1 minus p2 upon p1 raised to n minus 1 upon n. Now what we are doing, all this p2 upon p1 value, okay, these were transferring into the square bracket, okay, square root bracket. Therefore, this will become a2 upon v1 into p2 upon p1 raised to minus 1 upon n. If we transfer to numerator, it will become 1 upon n. And when we want to take these all values, a2 only where we want to put into put outside, then p2 upon p1, when it will transfer to the bracket, it will become p2 upon p1 raised to 2 upon n, because square root means where we have to make square and then afterwards square root, then value will be unchanged. And v1 1 upon v1 we are taking as a square root inside square root 1 upon v1 square. Okay, and then we are doing this, and we are getting m is equal to a2 into square bracket square root 2n upon n minus 1 p1 v1, this v1 square root will be going to denominator, so p1 v1 divided by v1 square, v1 v1 and 1 v1 will get cancelled. Okay, then p2 upon p1 raised to 2 upon n, okay, minus, so one we are multiplying this, okay, p2 upon p1 raised to n minus 1 upon n plus 2 upon n. And finally we are getting this equation. What is that? M is equal to a2 into square root 2n upon n minus 1 p1 v1 into bracket p2 upon p1 raised to 2 upon n minus p2 upon p1 raised to n plus 1 upon n. Am I right? I think it up to this we have completed last lecture. I have revised for 10 minutes. Am I right? Somebody can?
Yes, sir.
Okay.
Yes, sir.
Then with the help of above equation, one can calculate discharge of steam through the nozzle. So this equation. Now we have to go for condition for maximum discharge. Up till now everybody understood? Put your message in message box so that I can understand. Yes, 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 or no problem like this. Okay, so Suhas, no problem. Yes, 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 yes. Kunal, Pramod Avlikar, Diksha Admile, good, very good, Diksha. Good afternoon. Okay, Pramod Avlikar. Okay. Nikita Power, no problem. Okay, others shall I consider this as a representation? Okay. Now here and okay, before start of this lecture, I request you to tell your all other friends those are not attending the lectures that university has given one notice to us that examination of this semester may be conducted whatever the syllabus we have taught online during this semester. So definitely in physical classes there are less chances that there will be physical classes or a student you have to come to college. Less chances are there. Therefore, try to tell your friends those are not attending to attend the classes sincerely, and because examination will be conducted, attendance will be marked on this attendance only, online attendance. Okay. Now here we want to calculate the condition for maximum discharge. Okay. And for that, what we are doing is this mass flow rate equation or discharge equation of the nozzle is equal to what? A2 divided by 2n upon n minus 1 P1 upon V1 into bracket P2 upon P1 raised to 2 upon n minus P2 upon P1 raised to n plus 1 upon n. Okay, and this equation it depends on which quantity. Now this m is a variable quantity and it depends on which variables. M is a quantity, or you can consider M is a quantity, and it depends on number of variables. Okay, out of that, M depends on A2. M depends on N, adiabatic index of that steam. Okay, M depends on P1 also. M depends on V1, and M also depends on P2 upon P1. But if you see the equation A2, what is A2? Area of nozzle. Area of nozzle at throat. So this will be always constant. So it will not means it will not have any effect because it is the remaining constant. It may not have any variable effect on this M. Okay. Then N, what is N? Anybody? Adiabatic index of steam. And it is also for that steam, whatever the steam is flowing, it depends on the type of steam. So it will not have any kind of relation with the nozzle. So it is a property of steam. Adiabatic property. Adiabatic index means it is a individual property of the steam. Depending on the steam type, N depends. But it is not have any kind of relation with nozzle. So this P1 is the initial pressure of steam. Whatever the pressure is there, inlet pressure, so inside the nozzle, it is not having any kind of effect. Then small V1, it is a specific volume of steam at inlet of nozzle. Then on which important variable this M depend? Anybody? Others are constant with respect to nozzle. A2, N, P1, V1. Then it only depends on which factor? P2 upon P1. P2 upon P1, not P2 only. It is ratio. It is a critical pressure ratio. It depends on the pressure ratio value P2 upon P1. Okay. And therefore, when any equation depends on a particular variable, then we have to decide mathematical condition for maximization. Anything we want to maximize or anything we want to minimize. So in that case, the condition, mathematical condition is there that here this equation, main equation, we have to differentiate with respect to that variable. We have to differentiate that with respect to variable, and we have to equate that differentiation equal to 0. You would understand? What we want to do is there now. Here, whatever the equation of M depends on variable P2 upon P1. Okay. Therefore, to maximization condition we want. Therefore, what we are doing? So this M equation we are differentiating with respect to P2 upon P1 because it is a strongly it is varies with respect to P2 upon P1. M value strongly varies with P2 upon P1, and dm the differential of m with respect to P2 upon P1, and we have to equate that differential equal to 0. And then whatever the condition we are getting, so that condition is called as what? Condition for maximum efficiency. So this condition is a pure mathematical condition, and this used many times. Henceforth, you are going to use this condition in your engineering practices. What is that condition? The equation, main equation, we have to differentiate with respect to the variable, and we have to equate total differentiation equal to 0. Okay, and therefore, what we are doing now, the above equation, now write down condition for maximum discharge. So you did equation as equation number 2, or your number, whatever number is there. You have given, if you are given third number, it may be third equation. I don't know, the above equation, third or second, whatever is there, is depends on variable quantity P2 upon P1. Variable quantity P2 upon P1. Hence to obtain condition for maximum efficiency. Differentiating above equation with respect to P2 upon P1 and equating it to 0. Next, that is dm divided by d of P2 by P1 is equal to 0. Okay, everybody got this condition? Anything we have to go for maximization or minimization. This is the condition. The equation we have to find the equation on which variable it depends, and simple condition is there that equation we have to differentiate with respect to that variable, and we have to equate that differentiation equal to 0. This is the condition for anything we want to maximize, minimize, anything in. Okay, it is a mathematical condition. Okay, therefore, now this equation m. Now, if you see the equation, what do we this square root of 2n up a2 square root of 2n upon n minus 1 p1 v1, its differentiation, it will be acting as a constant. It will be acting as a constant. Okay, therefore it will become as a constant. Anything is there a square, it's a2 2n upon n minus 1 p1 v1, it will be acting as a constant. Therefore, write down constant into so what into, because why? Because this constant is equal to 0. Therefore, this constant divided 0 divided by constant, we are getting value 0. Okay, therefore we are writing as a constant into d of this differential equation, d m means d of d p2 by p1 into square bracket p2 upon p1. So only remaining thing is there that square root of p2 upon p1 raised to 2 upon n, p2 upon p1 raised to 2 upon n, minus p2 upon p1 raised to n plus 1 divided by n. N plus 1 divided by n. N plus n divided by is equal to 0. Okay. Now what we are doing here, this is a constant, or directly you can equate this constant will become 0, or let it be constant into now square root of p2 upon p1 raised to 2 upon n. Again, remember that it's square root, whatever the square root is there, this will be also acting as a constant. This some value will become okay. So this will be acting as a constant. So these all values into square root. Square root will also become what? Its differential will become one thing, and that will be constant. Therefore, only things inside the square root only we have to differentiate, because we have to. It is having some differentiation, but as it is equal to 0 afterwards, all these values will become equal to 0. Therefore, it will get cancelled, because it will become 0 when we will transfer all these values with respect to 0. Okay, and therefore constant into, okay, so differentiation inside this bracket, it will become p2 upon p1, so raised to 2 upon n. Its differentiation will be 2 upon n, p2 upon p1 raised to 2 upon n minus 1, minus n plus 1 divided by n raised to p2 upon p1 raised to p2 upon p1 raised to n plus 1 divided by n minus 1. Because everything square roots differentiation will also become one of the constant quantity. Hello, square root differential will become also one of the constant quantity. Am I audible?
Yes, sir, audible.
Okay.
Yes, sir, audible.
Okay. So constant divided by into 2 upon n raised to p2 upon p1 raised to 2 upon n minus 1, n plus 1 divided by n into bracket p2 upon p1 raised to n plus 1 divided by n minus 1. Only because then constant into 2 upon n, this we are simplifying it as a p2 upon p1 raised to 2 minus n divided by n minus n plus 1 divided by n into bracket p2 upon p1 raised to this n plus 1 minus n, and this n minus n will get cancelled, 1 upon n. Now as this constant is equal to 0, therefore this will become 0, and therefore constant will become go this side, it will become 0. Okay, and whatever remaining things are there now, this will become 0. 2 upon n into bracket p2 upon p1 raised to 2 up minus n upon n is equal to, so this will transfer to this side, 0 side, the RHS side. So it will become plus n plus 1 upon n into bracket p2 upon p1 raised to 1 upon n. Okay, now what we will do here, this constant will bring constants will bring to one side, and p2 upon p1 values will bring to one side. So this will become p2 upon p1 raised to 2 minus n upon n minus, this will transport this side going to numerator, sorry, going to denominator, and when we transport in numerator, 1 upon n will become minus 1 upon n, or indexing divide, here divide, same base is there, and if division is there, then index subtraction. 2 minus n upon n minus 1 upon n, p2 upon p1 raised to 2 minus n upon n minus 1 upon n is equal to n plus 1, and this 2 will transport to this side, it will become divide for going to divide denominator. So p2 upon p1 raised to 2 minus n upon n minus 1 upon n is equal to n plus 1 divided by 2. And in that case, if we simplify it, then p2 upon p1 is equal to 1 minus n upon n is equal to n plus 1 divided by 2. Okay, now then in that case, it will become p2 upon p1 n minus 1. If you go for this minus signature, okay, so this will become p2 upon p1 raised to minus, if you multiply this minus here also, what will do, or you can go for inverse. Okay, so p2 upon p1, it will become minus of, p2 upon p1 will become minus of, indexing minus 1 of, this will become minus in bracket 1 minus n, okay, divided by n. Okay, and it will become n minus 1, n minus 1 divided by n. Okay, but this will also if you reciprocate this, okay, then in that case this also we have to, this side also we have to make inverse, okay, reciprocal, then it will become 2 upon n plus 1, or we want value of p2 upon p1, so this p2 upon p1 is equal to 2 upon n plus 1 raised to, this will become n upon n minus 1, and this value is equal to what? This is the value of P2 upon P1 for which the discharge will be maximum. And this value, we have defined one pressure ratio for which the value, for which the uh, flow rate will be maximum or velocity will be maximum. So that pressure ratio, we are calling it as a, anybody? That pressure ratio, we are calling it as a, anybody? So that pressure ratio, we are calling it as a
Critical pressure.
critical pressure ratio. And this is
Critical
called
pressure.
as now critical pressure ratio value. P2 upon P1 is equal to what? 2 upon n plus 1 raised to n upon n minus 1. So this value of pressure ratio, which gives the maximum discharge or velocity, is called as critical pressure ratio. And this critical pressure ratio value depends on only value of n. What is the value of n? Adiabatic index. Okay, and therefore critical pressure ratio for superheated steam n is equal to 1.3 is equal to, if you put n is equal to 1.3 here, p2 upon p1 will become 2 upon n plus 1 raised to n upon n minus 1. If you put 1.3, we will get the critical pressure ratio value for superheated steam as a 0.546, and critical pressure ratio for dry and saturated steam n is equal to 1.135. If you put, then it will become 0.58. So these are going to be MCQ questions. Anybody having problem? If no problem is there, write yes. And have you written yes and written r? Sorry, yes and written WRITTN.
Sir, not written.
Not written. Okay, but understood. Write down understood. Yes. Okay. Then now I have to give some time to you. Let us this step you have written or not anything, not anything written. Somebody can represent. कोणी तर सांगा म्हणजे मला कळेल.
Up to this written, sir.
Up to this you have written na? Okay. So write down these steps. And when your write up is over this, you can put over. I can proceed to next steps. And this derivation is very important derivation, but lengthy, and you have to make practice of the derivation. Till that you will write, I will take attendance. After attendance, don't leave, because now time is there with me, therefore I am taking attendance. Today's date is 23rd. Okay. Roll number 1. लिहित सांगा बरं काय अटेंडन्स, नाही तर विसर चाल. Roll number 1 absent. 2 3.
Yes, sir. Roll number 2 present.
Okay, 3 absent. 2 present, 3 absent. 4 5.
Yes, sir.
5, yes. Okay, 5 present. 6 absent. 7 8 9 10 11
11
present.
present.
So 11 present. 12 13,
13 present, sir.
13 present, 11 present, 12 absent. Okay, 14, 15, 16, 17 present, Rushikesh. Okay, am I right now?
17 present.
Okay. Okay, 18, 19, 20, 21, 22 present, 23,
Yes, sir.
23 absent, 24, 25, 26, 27, 28, 29,
30 present, sir.
29 absent, 30 present, 31 present, 31 absent, 32,
Yes, sir.
33, 34,
32.
Yes, sir. 34.
30,
34 present, sir.
34 present, okay, 35,
Sir, 32
35.
present.
Yes, sir.
32 present, 34 present, okay, anything, 33,
35.
35
Yes, sir.
absent, 35 present, okay,
35. Yes, sir.
36, 35, okay, yes sir, present, 36, 37, 38,
38 present, sir.
38 present, okay, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53,
Yes,
54,
sir.
50,
53.
54, 55, 55, 56, 57,
57, sir.
57, 58, 59, 60,
59 present, sir.
59 present, 60, 61,
Yes, sir. Present 61.
62, 62, 62, 63,
Present, sir.
63
Present.
present, okay, 64, 65,
Yes, sir.
65 present,
Yes, sir.
null, okay, 66, 66, 67, 68, 69, 70, and 78 is also present. Anybody is there, you can put your attendance there.
47, sir.
47. Why you are giving late attendance?
Range problem, sir.
Yeah, 78 present now?
78 present. Yes.
Okay. Okay, I got it.
28 present.
28, Rutuja. I have taken your attendance. 60 also present. Mayur. Why you are giving not attendance? Mayur. Yedar. Okay. Okay, now about write up. 1 minute, sir. Write up completed up to this step.
Yes.
Okay. Who will up to what step? And okay. Remaining you can write. Up to P2 upon P1. You can write. Is screen available? Visible? Somebody can
Yes,
reply.
sir. Visible.
Screen visible? Visible ना? आहे का visible?
Yes, sir.
Yes, sir.
समजलं आमचं मागे लागते माझ्या मीटिंग घ्यायची मीटिंग. Hello. Is screen visible?
Yes, sir. Visible. Yes, sir.
किती वेळ लागतो सांगा लो. ठीक आहे. माझी किती स्कोट होती वय बचंड पोरांना माझी मागच्या वर्षी कंप्लीट करायचं ह्या वर्षी हा Okay. Now I think we completed up to this. P2 upon P1 is equal to P2 upon P1 raised to 1 upon n. Or P2 upon P1 raised to 1 minus n upon n is equal to n plus 1 divided by 2. And therefore, P2 upon P1 raised to n minus 1 upon n is equal to 2 upon n plus 1. And therefore, P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1.
सर n प्लस n मायनस 1 आपण n कसे येते?
P2 upon P1 raised to 2 upon n plus 1 raised to नाही n upon n minus 1 बरोबर आहे. इथं आपण हे केलं ना रेसिप्रोकल घेतलाय ना फक्त ह्याचा घास इकडे होणार काय म्हणा त्याला रेसिप्रोकल होणार ना घातांकाची इकडं स्क्वेअर रूट घेताना कसं आपण वन अपॉन एन घेतो ना तसं एन अपॉन याचा रेसिप्रोकल इकडे येणार 2 अपॉन n plus 1 रेस टू n अपॉन n minus 1 हे बरोबर आहे. मॅथमॅटिक्स थोडं बघा थोडं हे होते कन्फ्युजन होते पण इंडेक्सिंगचे लॉ 2 अपॉन n plus 1 P2 अपॉन P1 ह्या इकडचा होतं का रेसिप्रोकल होणार इकडे इंडेक्स n तर स्क्वेअर रूट घेतोय n रूट घेतोय आपण त्याला म्हणायचं ते n minus 1 upon n रूट असं म्हणू शकतो. therefore P2 upon P1 रेस इज इक्वल टू 2 upon n plus 1 फक्त इकडे घातांकाचं उलटा करतोय 2 upon n n upon n minus 1. ओके झालं लिहून सगळ्यांचं येस लिहा सगळ्यांनी. एनी हँग प्रॉब्लेम? Yes, if you have completed derivation, please write. I am here forwarding these notes to you, but still, जोपर्यंत मी फॉरवर्ड करत नाही मुद्दाम तोपर्यंत तुमच्याकडे पाहिजेत. ओके निकिता पवार ओव्हर श्वास ओव्हर ओके ओके द above equation of P2 upon P1 gives maximum velocity or maximum discharge and hence it is called as critical pressure ratio PC. Okay, critical pressure ratio value काय येणार आता 2 upon n plus 1 raised to n upon n minus 1. Okay. Let this value also right. MCQ they are going to ask or numericals we want this. Critical pressure ratio for superheated steam. काय येणार आता critical pressure for superheated steam is equal to n ची व्हॅल्यू फक्त या इक्वेशन मध्ये पुट अप करायची आपल्याला superheated steam मध्ये 2 upon n plus 1 2 upon 1.3 म्हणजे 2.3 2 upon 2.3 divided by raised to 1.3 divided by 0.3. ओके तर पुटअप केल्यानंतर तुमची व्हॅल्यू येते यांची सगळ्या कोणीतरी चेक करा नंतर 0.546 क्रिटिकल प्रेशर फॉर सुपरहिटेड स्टीम किती येते n इज इक्वल टू 1.3 घेत पुटअप केला त्या इक्वेशन मध्ये तर 0.546 आणि क्रिटिकल प्रेशर फॉर ड्राय अँड सॅच्युरेटेड स्टीम n इज इक्वल टू 1.135 आणि इतर पुटअप केला तर आपली किती येते व्हॅल्यू 0.58. वेट स्टीमचा आपण ड्राय इन्स्पेक्शन माहित असेल तरच काढू शकतो. वी कॅनॉट कॅल्क्युलेट फॉर वेट स्टीम. एक्स माहित असेल तर आपण एन काढू शकतो आणि एन माहित झाल्यानंतर तोच इक्वेशन क्रिटिकल प्रेशर रेशोचं तेच इक्वेशन वापरायचं. ओके ओव्हर. ओके सो क्रिटिकल प्रेशर रेशो फॉर ड्राय अँड सॅच्युरेटेड स्टीम एन इज इक्वल टू 1.135.58. ओके आता हेच इक्वेशन आता आपल्याला काय करायचंय मॅक्झिमम व्हेलॉसिटी ऑफ स्टीम थ्रू नोझल. आता काय करायला लागलं आपल्याला फक्त ह्या इक्वेशन मध्ये फक्त P2 अपॉन P1 ची व्हॅल्यू पुटअप केली आपण काय कुठली व्हॅल्यू 2 अपॉन n प्लस 1 रेस टू n अपॉन n मायनस 1 ह्या इक्वेशन पुटअप केल्यानंतर जी व्हॅल्यू आपल्याला मिळेल C2 ची ती काय असेल मॅक्झिमम व्हेलॉसिटी आणि त्याला आपण नोटेशन काय वापरले C मॅक्स. ओके लिहा आता द मॅक्झिमम व्हेलॉसिटी ऑफ स्टीम थ्रू नोझल. नाउ आय विल यू राईट विथ मी त्यात लिहिल्यानंतर maximum velocity of steam through nozzle Make heading. The velocity of steam through nozzle is given by. Write down that. The velocity of steam through nozzle is given by. आपलं इक्वेशन नंबर 1 तुमचं 1 असेल ते पहिले इक्वेशन. Velocity of steam through nozzle is given by C2 is equal to 2 into n upon n minus 1 2 into n upon n minus 1 P1 V1 into bracket 1 minus P2 upon P1 raised to n minus 1 upon n. आता ह्याच्यामध्ये काय करायला लागलं आपल्याला P2 upon P1 ची व्हॅल्यू किती आहे 2 upon n plus 1 raised to n upon n minus 1 ती व्हॅल्यू पुट अप करायची फक्त क्रिटिकल प्रेशर रेशोची. ओके राईट डाऊन. substituting value of critical pressure ratio that is P2 upon P1 is equal to a value त्याची 2 upon n plus 1 raised to n upon n minus 1 2 upon n plus 1 raised to n upon n minus 1 हे जर पुटअप केले ह्याच्यामध्ये एक पुटअप करायची. देअरफॉर C2 इज इक्वल टू आता C2 ज्यावेळेस आपण व्हॅल्यू क्रिटिकल प्रेशर रेशोची व्हॅल्यू आपण पुटअप करेल तर त्या प्रेशर रेशोला व्हॅल्यूसाठी किती असते.
सेंटेन्स रिपीट करा.
काय झालं
सेंटेन्स रिपीट करायचं.
काय झालं
सबस्टिट्यूटिंग
व्हॅल्यू ऑफ क्रिटिकल प्रेशर रेशो in above equation. Substituting value of critical pressure ratio in above equation that is P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. Or good, Prathamesh, shall I proceed?
Yes, sir.
Okay. आता हे जर पुटअप केली आपण C2 तर C2 ला काय म्हणावं लागलं आपल्याला आता मॅक्झिमम व्हेलॉसिटी म्हणजे C मॅक्स याला आपण काय म्हणतो आता देअरफॉर C मॅक्स इज इक्वल टू C2 चं नाव बदलणार आपण C मॅक्स कारण आपण क्रिटिकल प्रेशरची व्हॅल्यू आपण पुटअप करतोय. लिहा आता देअरफॉर C मॅक्स इज इक्वल टू स्क्वेअर रूट ऑफ फक्त P2 अपॉन P1 ची व्हॅल्यू फक्त आपल्याला 2 अपॉन n plus 1 raised to n upon n minus 1 पुटअप करायची. देअरफॉर C मॅक्स इज इक्वल टू स्क्वेअर रूट ऑफ 2 n upon n minus 1 into P1 V1 into bracket 1 minus आता P2 upon P1 ची व्हॅल्यू किती आहे 2 upon n plus 1 raised to n upon n minus 1 त्याचा रेस टू किती घातांक आहे n minus 1 upon n. ओके मग त्यानुसार आता बघा देअरफॉर C मॅक्स इज इक्वल टू स्क्वेअर रूट ऑफ 2n अपॉन n मायनस 1 P1 V1 मध्ये काय चेंज होणार नाही 1 मायनस आता हा n अपॉन n मायनस 1 रेस टू n मायनस 1 अपॉन मल्टिप्लिकेशन असणार. इंडेक्सिंगचा इंडेक्स म्हणजे ओके इंडेक्सिंगचा इंडेक्स म्हणजे मल्टिप्लिकेशन n अपॉन n मायनस 1 इनटू काय n मायनस 1 अपॉन n n minus 1 आणि n minus 1 n will get cancelled. Okay, therefore C max is equal to काय येणार 2n upon n minus 1 P1 V1 okay into bracket 1 minus आता सगळं गेल्यानंतर काय येणार खाली 2 upon n plus 1. Therefore C max is equal to C max is equal to 2 into n upon n minus 1 P1 V1 into bracket n plus 1 okay minus 2 divided by n plus 1 n plus 1 minus 2 divided by n plus 1 okay plus 1 and minus 2 minus 1 okay therefore it will become what C max is equal to 2 upon square root of 2 into n upon n minus 1 P1 V1 into bracket n minus 1, okay, divided by n plus 1. इथला n minus 1 आणि इथला n minus 1 will get cancel. One multiplication आहे. Final काय राहते? C max is equal to square root of 2 into n upon n plus 1 into P1 V1. With the help of this equation, one can find out the maximum velocity through the nozzle of steam through the nozzle. Max is equal to square root of 2 into n upon n minus 1. It depends on what? N and P1 V1, initial condition of steam. Understood? Return. Shall I give some time for 2 minutes? ओव्हर ज्यांनी समज वाय आणि ओव्हर वाय कॉमा ओव्हर जर समज असेल त्यांनी पुट Kunal, okay, Kunal, now yes, understood and return over y comma over. This means I will understand that your write up is also over. Understood and write up is also over. Okay, Nikita power over. Understood. Y comma over you can put. Okay. No problem. I think it may be very simple. Rahul Chaudhary, Kunal Kedar, Kunal, Rahul and Nikita. Only they have given answers. Y comma over. Y for understood and over for write up is over. Kunal, last lecture absent?
Yes, sir.
How? Let's the problem.
Sir, electric problem होता चार.
ओके ओके. समजलं का? लिहून घेतले का नोट्स मागच्या?
हो सर, कम्प्लीट आहे.
ओके. Others complete over. Write fast so that I can proceed to next. So this derivation I request you to practice. Right on page, write at your own all steps again. Remember, try to remember all the steps and write this. You give on PDF of it. Submit to that test mail. Whatever I have given one mail to you for submitting test. That on that mail you here. Once again you solve the derivation on good page, neat page, and then you submit on that mail me223 at about gmail.com that way. Okay, Prathamesh Patil, yes, and over. Nikita Power, yes. Okay, over. Understood. Okay. Now Cmax is equal to that way gone. Now we want to calculate maximum discharge through the nozzle. This is maximum velocity. Now we want to calculate maximum discharge. And for that also what we will do? Anybody? Whatever the equation of discharge is there, EM equation is there. That equation encloses P2 upon P1 value. So in that P2 upon P1 value, we have to only substitute. And we have to simplify the equation. Okay, write down. Dividing maximum discharge through nozzle. Maximum discharge through the nozzle. Write down. The discharge or mass flow rate. Discharge or mass flow rate through nozzle is given by. The discharge or mass flow rate through nozzle is given by. Write down. M is equal to A2 into square root. A2 into square root काय ना ते आपलं इक्वेशन मगाच 2 into n upon n minus 1 Write with me, yeah. P1 upon V1 into bracket into square bracket. Square root मतलब square bracket. P2 upon P1 raised to 2 upon n minus P2 upon P1 raised to n plus 1 divided by n. ओके. आता याच्यामध्ये आता क्रिटिकल प्रेशर रेशियोची व्हॅल्यू जी आपण काढलेली आहे P2 upon P1, दिस व्हॅल्यू हॅव टू पुट, देन दिस m will be called as m max, maximum discharge. Putting value of P2 upon P1, putting value of P2 upon P1 in above equation, putting value of P2 upon P1 in above equation, that is P2 upon P1 is equal to P2 upon P1 is equal to 2 upon n plus 1, 2 upon n plus 1 raised to n upon n minus 1. ती आपण व्हॅल्यू मग काढलेली, तीच व्हॅल्यू ते सबस्टिट्यूट करायची. Okay, voice is breaking. Okay. Okay. So I think your net problem. Others, whether voice is breaking?
Yes, sir. Maybe.
Okay. Rahul, I think your internet connection you check. Rahul Chaudhary. Okay. Putting value of P2 upon P1 as critical pressure, so that is P2 upon P1 is equal to 2 upon n plus 1 raised to n upon n minus 1. Okay. Put that value. Now, shall I go to next page?
Yes, sir.
Okay. Others, please reply through SMS or Kunal only give an answer.
Yes, sir.
Okay, okay. Nikita also telling, okay, go to next page. Okay. Then, therefore, m is equal to, sorry, m will be called as now m max. Okay. M max is equal to, okay, A2 into square root. आता हे व्हॅल्यू खूप मोठे आहेत बरं का, एकदम आपल्याला A2 into square root 2 into n upon n minus 1, 2 into n upon n minus 1, P1 upon V1 with curly bracket. Okay, in bracket now P2 upon P1 value we have to put P2 upon P1 value 2 upon n plus 1 raised to n upon n minus 1 raised to 2 upon n minus P2 upon P1 value पुन्हा 2 upon n plus 1 raised to n upon n minus 1, 2 upon n plus 1 raised to 2 upon n minus 1 raised to n plus 1 divided by n. Curly bracket complete. Here what we'll do now, this will simplify now. Therefore A2 into bracket into A2 into square root 2 n upon n minus 1 P1 V1 कर्ली ब्रॅकेट किंवा स्क्वेअर ब्रॅकेट ठेवा, काय स्क्वेअर ब्रॅकेट ठेवा वाटल्यास, त्यांनी कर्ली ठेवली स्क्वेअर ब्रॅकेट. आता 2 upon n plus 1 raised to n upon n minus 1 आणि 2 into 2 upon n, n will get cancel. इथे काय येणार फक्त इंडेक्सिंगचा इंडेक्स म्हणजे मल्टिप्लिकेशन 2 upon n minus 1, n will get cancel 2 upon n minus 1 minus अगेन दुसऱ्या ब्रॅकेट मध्ये 2 upon n plus 1 raised to इथला पण n minus n आणि n will get cancel. I will याच्यामध्ये n plus 1 divided by n minus 1 ओके, n प्लस 1 डिवाइड बाय n मायनस 1, स्क्वेअर ब्रॅकेट ठेवा, कर्ली ब्रॅकेट ठेवा. ओके, लिहून झाला असेल तर ओके. ओके, 2 स्टेप. ओके, पुढच्या स्टेप. शॅल आय गो टू नेक्स्ट स्टेप? Now what I will do is there in this here equation, this 2 upon n plus 1 raised to n plus 1 divided by n minus 1, this we have to take outside the bracket. एवढंच फक्त करायचं पुढच्या स्टेपला. ओके, तर पुढच्या स्टेपला काय केलं आपण? ओके, 2 upon max is equal to a2 into square root 2 into n upon n minus 1 p1 upon v1. आता फक्त काय करतोय आपण, इकडचं जे n 2 upon n plus 1 raised to n plus 1 divided by n minus 1 will take common. Okay, therefore what will be there? 2 upon n plus 1 raised to n plus 1 divided by n minus 1 will take common. ओके, मग बेसचं समान आहे, फक्त बेसचा काय प्रॉब्लेम, बेस दोघांचा समान आहे. देअरफॉर इन ब्रॅकेट मध्ये काय 2 अपॉन n प्लस 1 रेस टू. आता हे कॉमन काढणं म्हणजे आपण काय करतो, तर कॉमन काढणं म्हणजे डिवाइड करणे. याला नसेल तर डिवाइड करणे म्हणजे घातांकाची पुन्हा सबस्ट्रॅक्शन. म्हणजे 2 अपॉन n प्लस 1 रेस टू 2 अपॉन n मायनस 1 मायनस काय येणार, मायनस n मायनस 1. ओके, सॉरी घातांकाची काय वजाबाकी होणार, म्हणजे काय होणार, म्हणजे डिनॉमिनेटर असल्यामुळे वजाबाकी मायनस इन ब्रॅकेट n मायनस 1 डिवायडेड बाय n प्लस 1. मग किंवा आपण काय करतो, n मायनस केलं, n मायनस 1 डिवाइड बाय n प्लस 1. आता हे आपण काय केले, ह्याला -1 मल्टिप्लाय आणि डिवाइड केले, जेणेकरून आपला इंडेक्स डिनॉमिनेटर काय आला पाहिजे, n मायनस 1. देअरफॉर ह्याच्यामध्ये आपण चेंज काय केलं की ह्याला फक्त काय केलं, n प्लस 1 म्हणजे मायनस n. ओके, म्हणजे 1 मायनस n आहे, मायनस n प्लस 1 डिवाइड बाय n मायनस 1. ओके, देअरफॉर इथं सबस्टिट्यूट केलं इथलं. देअरफॉर आता इथं काय केलं, n प्लस 1 n मायनस 1 डिनॉमिनेटर आहे, कॉमन आहे, इथं बाकीचं काय चेंज राहत नाही. देअरफॉर m मॅक्स इज इक्वल टू a2 into square root of 2 into n upon n minus 1 p1 upon v1 raised to 2 upon into 2 upon n plus 1 raised to n plus 1 divided by n minus 1, no change, into bracket 2 upon n plus 1 raised to, आता इथे काय n minus 1 डिनॉमिनेटर सेम, 2 minus n minus 1. ओके, 2 minus n minus 1 minus 1. Okay, therefore m max is equal to e काय सगळं सेम, a2 into square root of 2 into n upon n minus 1 into p1 upon v1 into bracket 2 upon n plus 1 raised to n plus 1 divided by n minus 1 into bracket. now 2 upon n minus 1, तर 2 minus 1 म्हणजे 1 minus n minus 1. ह्या इथे चुकलेलं आहे. आपण आता इथे काय करतोय, बेस रेसिप्रोकल करतोय. बेस रिसिप्रोकल केल्यानंतर इथं काय होणार, मायनस इंडेक्सला काय होणार, मायनस साईन होणार. म्हणजे लिहा एम मॅक्स इज इक्वल टू A2 आहे तसं स्क्वेअर रूट मध्ये 2 इंटू एन अपॉन एन मायनस 1, 2 इंटू एन अपॉन एन मायनस 1 P1 अपॉन V1 इंटू ब्रॅकेट 2 अपॉन एन प्लस 1 रेस टू एन प्लस 1 डिवाइड बाय एन मायनस 1 इंटू ब्रॅकेट. आता हे आपण काय करतो, बेस रेसिप्रोकल उलटा करतो, म्हणजे एन प्लस 1 डिवाइड बाय 2. इथंच करतोय आपण एन प्लस 1 डिवाइड बाय 2. सॉरी नाही, ते काय नाही, काय सॉरी, बेस उलटा करत नाही, तेच ठेवतोय आपण. सॉरी 2 अपॉन एन प्लस 1 नाही, 2 अपॉन एन प्लस 1च आहे रेस टू. आता हे काय करतोय आपण, 1 मायनस एन म्हणजेच काय, मायनस इन ब्रॅकेट 1 मायनस एन म्हणजे काय, मायनस इन ब्रॅकेट एन मायनस 1. याचा अर्थ तोच आहे, मायनस ब्रॅकेटच्या बाहेर काय काढलं, मायनस साइन काढलं तर मायनस एन आणि प्लस 1. याचा अर्थ मायनस इंटू ब्रॅकेट एन मायनस 1 अपॉन एन डिवाइड बाय एन मायनस 1 आणि मायनस 1. आता हे एन मायनस 1 आणि एन मायनस 1 विल गेट कॅन्सल. इथे काय राहणार, फक्त 2 अपॉन एन प्लस 1 रेस टू मायनस 1. मायनस 1 म्हणजे काय, याचा बेसचा रेसिप्रोकल एन प्लस 1 डिवाइड बाय 2, म्हणजे इथं मायनस 1 कॅन्सल करायचं. तर देअरफॉर एम मॅक्स इज इक्वल टू A2 इंटू स्क्वेअर रूट ऑफ 2 इंटू एन अपॉन एन मायनस 1 P1 V1 इंटू ब्रॅकेट 2 अपॉन एन प्लस 1 रेस टू एन प्लस 1 डिवाइड बाय एन मायनस 1 ॲज इट इज इंटू ब्रॅकेट स्क्वेअर ब्रॅकेट टाकलं चालेल काय. ओके, एन प्लस 1 कारण इथं मायनस 1 आहे, म्हणजे एन प्लस 1 डिवाइड बाय 2 आणि मायनस 1. ओके, नाउ this we have to simplify. Now n plus 1 minus 2 divided by 2. Okay, therefore m max is equal to A2 into square root 2 into n upon n minus 1 P1 upon V1 into 2 upon n plus 1 raised to n plus 1 divided by n minus 1 into bracket. तर काय करतोय आपण, n plus 1 minus 2 divided by 2, n plus 1 minus 2 divided by 2. सिम्प्लिफिकेशन काय सांगते, एम मॅक्स इज इक्वल टू A2 इंटू स्क्वेअर रूट ऑफ एन अप 2 इंटू एन अपॉन एन मायनस 1 P1 अपॉन V1 इंटू ब्रॅकेट 2 डिवाइड बाय एन प्लस 1 रेस टू एन प्लस 1 डिवाइड बाय एन मायनस 1 इंटू ब्रॅकेट काय एन मायनस 1 डिवाइड बाय 2. तर हे 2 आणि एन मायनस 1 दोन्ही पण गेट कॅन्सल. इथला 2 आणि एन मायनस 1 एन मायनस 1 अपॉन 2 गेट कॅन्सल. देअरफॉर एम मॅक्स इज इक्वल टू maximum mass flow through nozzle is given by A2 into square root of n into P1 upon V1 into bracket 2 upon n plus 1 raised to n plus 1 divided by n minus 1. Understood? आणि रिटर्न राईट y and over. म्हणजे तुमचं ज्याला अंडरस्टँड नसेल तर यू कॅन आस्क, काय स्टेप समज नसेल तर, काय चुकलं असेल माझं तरी पण सांगा. थोडं सगळ्या मॅथमॅटिकल ऍडजस्टमेंट आहेत. सगळ्या डेरिव्हेशन म्हणजे 80% पार्ट हा मॅथमॅटिकल ऍडजस्टमेंट्स असते आणि बाकीचे 20% फक्त प्रिन्सिपल किंवा थिअरी. अंडरस्टूड? राईट युअर मेसेजेस. गौरव गुड, असंच द्या गौ, वाय यस आणि ओव्हर गुड. शुभम यस ओव्हर, कुणाल यस ओव्हर, कुणाल शेट्टी यस ओव्हर गुड, शनेश्वर ऑल्सो यस ओव्हर गुड, राहुल खडके यस ओव्हर गुड, राहुल. प्रमोद ऑल्सो यस ओव्हर. ओके, बालाजी यस ओव्हर, व्हेरी व्हेरी गुड. प्रॅक्टिस करा आज मॅग्रा डेरिव्हेशनची. हे आपलं मॅक्झिमम डिस्चार्ज थ्रू द नोझल. कोणाला काय प्रॉब्लेम? निकिता पवार, Suhas is there in lecture? Suhas Naste? No problem. Okay. You have not written your message, Nikita. Okay. Suhas.
Yes, sir.
Where you over na? Okay. Good. Sorry. Yeah.
Yes, sir.
Chalo. So from above equation,
सर
anything. बोला की.
जेव्हा आपण तिथून 2/n+1 रेस टू n+1/n-1 कॉमन काढतो
हा.
तेव्हा ती छेदाचं इकडे वर घेतल्यावर -n+1/n-1 राहते ना.
कुठं?
2/n+1 रेस टू n+1/n-1 कॉमन काढल्यावर आपण
हा.
ते कॉमन
कॉमन
काढल्यानंतर
काढल्यानंतर इथं
मग
-1 येणार. इथं काय प्रॉब्लेम? 2/n+1.
अंशाला
इथं काय
तिथं मग 2/n-1 -n+1/n-1
हा
येणार
सर
ना.
हा सर करेक्ट आहे त्याचं.
2/n+1 रेस टू काय येणार? 2/n n+1.
-n+1/n-1
2/n+1. डिवायडेड बाय n+1 म्हणजे त्या मायनस येणार बरोबर की -n-1
-n+1/n-1 नंतर मग ते मायनस आत घेतल्यावर ते मायनस जर ते अंशाला मायनस घेतलं तर मग +1 होतं तिथं.
एक मिनिट. 2/n-1 -n-1 आणि इथं खाली कुठे आहे आपलं n-1. -n+1 -1.
इक्वेशन बरोबर आहे पण जर तिथं चिन्ह तुम्ही मला म्हणला ना छेदाला n-1 आणि अंशाला n+1
बरोबर आहे तुमचं बरोबर आहे. नाही इथं काय झालंय लक्षात आलं का? इथं घेताना आपण ते घेतले, पुढच्या स्टेपला तेच घेतलंय. म्हणजे 2 ब्रॅकेटमध्ये काय येणार? मायनस येणार. ओके. मायनस दिल्यानंतर आहे तेच राहणार बरोबर आहे. n+1 डिवाइड बाय n-1 मायनस साईन दिलंय आपण इथं त्याला काय.
येस बरोबर.
फक्त इथं ब्रॅकेट आहे का नाही? ब्रॅकेट टाकायचं राहिलं त्या म्हणजे इथं ब्रॅकेट टाकायचं आपण.
जर आपण अंशाला मायनस घेतलं तर मग खाली शेजारा प्लस होत आहे ते.
तेच नाही इथं मायनस घेतलं की आपण त्यामुळे गरज नाही काय करायची. म्हणजे मगाशी म्हणलं ना मी तुम्हाला वर्ग घेताना तर मायनस साईन दिले की त्याला. इथं मायनस साईन दिलंय फक्त ब्रॅकेट टाकल्यामुळे ब्रॅकेट टाकला तर अति बरं वाटते. तर खाली लिहिताना लिहिलंय आपण 2 - n आणि ह्या मायनस मायनस विल बिकम सॉरी मायनस प्लसचा मायनस साईनचा इफेक्ट आत दिला तर काय होईल? मायनस. घेताना केले ऑपरेशन बरोबर. 2 - n -n1 बरोबर आहे की. प्रथमेश बरोबर आहे का? 2/n- इथं मायनस साईन दिलंय आपण. मायनस फक्त ब्रॅकेट टाकायचं. मग इथं मायनस व n केलंय आपण आणि मायनस आतमध्ये जर
तुम्ही मगा म्हणला n-1/n+1 म्हणला.
नाही मग चुकून एक मी गडबडीत झालं सांगताना. ठीक आहे. स्टेप्स आर करेक्ट ना?
येस स्टेप्स आर करेक्ट.
करेक्ट ठीक आहे. एनिथिंग चुकून एक गडबडीत एक सांगताना कसं आहे इथं एक्सप्लेन सगळं वाच सांगताना चुकून झालं स्लिप ऑफ टंग. इथे मायनस साईन दिल्यामुळे गरज नाही ते आपण म्हणतोय डिनॉमिनेटरला मायनस साईन गेल्यामुळे. ओके. डिनॉमिनेटर वर घेतलं तर मायनस साईन देतोय आपण त्यामुळे काय प्रॉब्लेम नाही. म्हणजे डिव्हिजन म्हणजे इंडेक्सची सबट्रॅक्शन त्यामुळे ती येत. ठीक आहे. एनिथिंग स्टेप्स आर करेक्ट. ओके. किती वेळ राहिला आपला अजून? 5 मिनिट राहिले अजून. ठीक आहे. मग विथ आलेलं का हे फ्रॉम अबव इक्वेशन मॅक्झिमम डिस्चार्ज ऑफ स्टीम थ्रू नोझल कॅन बी डिटरमाइंड. आता काय करू? बारक आर्टिकल जे आपण मागे आपण रिव्हिजन मध्ये घेतलं होतं हे राहू द्या. मॅक नंबर. दिस वे डिफाईन मॅक नंबर लास्ट लेक्चर.
नो सर.
ठीक आहे, लिहा. मॅक नंबर इन ब्रॅकेट कॅपिटल एम. मॅक नंबर इन ब्रॅकेट कॅपिटल एम. इट इज अ डायमेन्शनल लेस नंबर. म्हणजे याला डायमेन्शन नसतात. लिहा. इट इज अ डायमेन्शनल लेस नंबर. इट इज अ डायमेन्शनल लेस नंबर and is defined as, it is a dimensional less number and is defined as ratio of square root of square root of inertia force to elastic force. Inertia force to elastic force. मॅक नंबर म्हणजे काय, स्टँडर्ड डेफिनेशन काय त्याची, इट इज स्क्वेअर रूट ऑफ रेशो ऑफ स्क्वेअर रूट ऑफ इलेस्टिक inertia force to elastic force. It is denoted by m. It is denoted by m, capital M. Mathematically, Mach number in bracket capital M is equal to square root of inertia force to elastic force. Square root of inertia force to elastic force. Next line, therefore Mach number is also defined as, ही डेफिनेशन आपली खूप महत्वाची आहे आपल्याला. हे जर समजले वाटले, आवड वाटली राहील नाही. Mach number is defined as ratio of velocity of object to the velocity of sound. Velocity of object to velocity of sound. Okay. Yeah. Therefore, m is equal to, Mach number m is equal to velocity of object divided by velocity of sound. Yeah. Therefore, m is equal to, इथे वाटलं हे सी ऑब्जेक्ट लिहिते त्याच्या आपण व्ही लिहूया. वेलॉसिटी ऑफ ऑब्जेक्ट म्हणजे सी लिहूया. सी डिवाइडेड बाय सी एस. सी म्हणजे वेलॉसिटी ऑफ ऑब्जेक्ट आणि सी एस म्हणजे वेलॉसिटी ऑफ साऊंड. एम इज इक्वल टू सी डिवाइड बाय सी एस. Velocity of object divided by velocity of sound. Right done now. Depending on Mach number, flows are classified as. Depending on Mach number, flows are classified as. Right done. Subsonic flow. कारण velocity of steam through nozzle is always greater than velocity of sound. म्हणजे जास्त असते आणि त्याचं युनिट नेहमी मॅक नंबर मध्ये मोजतात. Velocity of steam through nozzle जास्त velocity असल्यामुळे it is always measured in terms of velocity of sound. मॅक नंबर मध्ये. ओके. सबसोनिक फ्लो. सबसोनिक फ्लो काय सांगितलं आपण डेफिनेशन सबसोनिक फ्लोची? एनीबडी? मागचं सांगितलं तुम्हाला सबसोनिक फ्लो. सबसोनिक फ्लो एनीबडी?
साऊंड पेक्षा कमी.
साऊंड पेक्षा कमी म्हणजे काय? वेन वेलॉसिटी ऑफ ऑब्जेक्ट किंवा एनी वेव्ह आपल्या स्टीम, वेन वेलॉसिटी ऑफ ऑब्जेक्ट इज लेस दॅन velocity of object is less than velocity of sound. When velocity of object is less than velocity of sound, then that type of flow is called as, subsonic flow. That type of flow is called as subsonic flow. सबसोनिक फ्लो ला मॅक नंबर किती असेल? काय असेल? एक असेल का एकपेक्षा कमी असेल का एकपेक्षा जास्त असेल? वेलॉसिटी ऑफ ऑब्जेक्ट कमी आहे वेलॉसिटी ऑफ साऊंड पेक्षा, म्हणजे मॅक नंबर काय असणार? एक पेक्षा. एनीबडी? सी ऑब्जेक्ट मिनिमम डिवाइड बाय मॅक्सिमम क्वांटिटी
कमी असणार.
कमी असणार. ओके. म्हणजे लिहा. फॉर सबसोनिक फ्लो सी ऑब्जेक्ट इज लेस दॅन सी एस. सी ऑब्जेक्ट इज लेस दॅन सी एस. Therefore, Mach number is always less than 1. M is less than 1. M is less than 1. आता पुढचा फ्लो सोनिक फ्लो. सोनिक फ्लो. सोनिक फ्लोला काय असतं? velocity of object and velocity of sound काय असतील? both are equal. If the velocity of object is equal to velocity of sound, then that type of flow is called as sonic flow. And that type of flow is called as sonic flow. For sonic flow, C object is equal to CS. Object velocity is equal to velocity of sound. CS म्हणजे velocity of sound. आणि C किंवा C object म्हणजे velocity of object. And for sonic flow, M is equal to किती असणार? Anybody?
Greater equal.
Equal to 1. हा. For sonic flow, M is equal to 1 कारण C is equal to CS. Ratio same. Okay. Then supersonic flow. सुपरसोनिक फ्लो म्हणजे काय? एनिबडी? इंटरव्ह्यूला वगैरे विचारतील मॅक नंबर. त्यासाठी आपल्याला जास्त थिअरी याचे अनालिसिस नाही आपल्याला, पण इन टर्म्स ऑफ इंटरव्ह्यू
Velocity of object is more than velocity of sound.
करेक्ट. वेलोसिटी ऑफ ऑब्जेक्ट इज ग्रेटर दॅन वेलोसिटी ऑफ साऊंड और मोर दॅन वेलोसिटी ऑफ साऊंड. म्हणजे आता जे आपले रॉकेट्स वगैरे आहेत, आपले सॅटेलाइट्स आहेत आपण सोडतो, त्यांची वेलोसिटी इज ऑलवेज ग्रेटर दॅन वेलोसिटी ऑफ साऊंड. विथ व्हेरी जे आपण मंगळावर यान सोडलेलं होतं, ओके, ते ज्या रॉकेट किंवा ज्या सॅटेलाइटनं सोडलं होतं त्या सॅटेलाइटची वेलोसिटी शुड बी ऑलवेज ग्रेटर दॅन वेलोसिटी ऑफ साऊंड. Supersonic flow. If velocity of object is greater than velocity of sound, then that type of flow is called as supersonic flow. And for supersonic flow, C object is greater than CS and M is greater than 1. Understood? Mach number and 3 types of flows of Mach number. हे पुढचे याच्यावर एवढंच आहे. ब्राईट शॉर्ट नोट्स ऑन मॅक नंबर म्हणून येते आपल्याला, कारण स्टीमचा जो फ्लो आहे थ्रू नोझल इज हियर इट्स व्हेलॉसिटी इज जनरली डिफाइंड इन टर्म्स ऑफ मॅक नंबर और एम और व्हेलॉसिटी ऑफ साउंड. ओके, सो मॅक नंबर रिटर्न and understood. Last message of today's lecture. Rahul Chaudhary only given yes, so yes sir. Others please give your message and then we'll. Prathamesh yes, yes. Kunal yes, over. Gaurav yes, over. So today's my homework is there to all of you is that whatever the derivation we have solved today, please write in on one page and submit it on a test or on mail, whatever mail I have given to submit the test. Okay. So with this, shall I conclude today's session?
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you for attending lecture. Okay. Thank you. We'll conclude.